All right, hey gang, we're going to go ahead and take a look at section, let's see here, 2.7. We're going to work through some of these problems here just to make sure you remember the different rules that we talked about the other day, and then I'm going to have you finish up the rest of those from there. So taking a look at the first section here, let me go ahead and look at this. It says here, classify the relationship between each pair as alternate interior, alternate exterior, corresponding, or consecutive interior. Okay, so as I look at this, just a quick review. Alternate interior, you have a transversal. They alternate across that transversal between the two lines that the transversal intersects. So if we look down here, this line right here, we have a transversal, and a pair of alternate interior would be like 11 and 13 or 10 and 16. Okay, now what I like to do to make sure that you are seeing everything correctly, we're looking at 2 and 10. I'm going to go ahead and cover up that portion right there, okay? You no longer can see the other lines, and now hopefully it will be more clear which angles we're referencing. 2 and 10, the angles that we're referencing right here would be in the same position, upper right-hand corner and upper right-hand corner. So I'm going to go with the fact that angles 2 and 10 are going to be corresponding angles. And that's the angle symbol right there if you want to use that. Okay. Alternate exterior, since we talked about alternate interior and we talked about corresponding, alternate exterior, again, if I cover up this line right here, the exterior angles would be on the outside, 1 and 4 and 6 and 7. So if they're alternating, we're going to go with 4 and 6 as alternate exterior, and 1 and 7 would be considered alternate exterior. Okay. The last one, consecutive interior angles. If I go ahead and cover up this line again right here, what I notice right here is that when they're consecutive interior, on the inside, like 4 and 9, oftentimes we refer to them as also same side interior. Or you could also do 3 and 10 would be same side interior angles. Okay, so just a couple of things to think about there with how to classify those angles. As I look down at the next section, it says this: name the transversal that forms a pair of angles. Then identify the special name of the angle pair. So 2 and 12, if I look at 2 and 12 right there, here's what I'm seeing. If I was to redraw the picture, 2 and 12 will look something like this. Okay, now remember, the transversal is the line that both of them reside on. Okay, which ones share? The line that's shared is the transversal. So I'm going to say the transversal is line A. Okay, then from there, identifying the special name, do we see that they're on the inside of these two lines and they alternate across that transversal? So I'm going to say that these are alternate interior angles. Okay, alternate interior angles. All right, so again, you want to finish that up for the next 3. The last section on the front side deals with actually giving us angle measurements. Okay, now you'll notice that this line is parallel to this line. These two are not parallel. That's going to be key. Okay, so when I look at angle 2, I'm going to put down that this is 92 degrees. Okay, and angle 12 is 74 degrees. Okay, now if I'm looking at number 11, what's the measure of angle 10? Here's what we need to do. We have to, in order to have any of the relationships, tell which postulate or theorem you use. In order to know the relationships, we have to know that they have to be based on parallel lines. So again, if we have alternate interior angles with parallel lines, you have alternate interior angles that are congruent. If you have corresponding angles, they have to be congruent. And then the consecutive interior angles or same side interior angles have to be supplementary. Okay, and those are the 3 major ones that we're going to be using as far as the postulates or theorems. So I'm not too concerned if you mix these 2 terms up. Okay, so what I'm going to do is this. Angle 10, we want to know that measurement. So what I know is this, that these lines are the lines that are parallel, not these. So I know that I want to draw this transversal and then draw line M and line N. Okay? Angle 2 is up here at 92 degrees. Okay? Angle 10 is down here. So what's the measure of angle 10? Well, angle 10 is going to be 92 as well. And I'm going to say because the corresponding angle is postulate. Again, you don't have, postulate or theorem, if you get that mixed up, is not a big thing ID to me, but I do want you to know we want to identify the type of angles we're working with, okay? Some people would get this wrong because they would say, hey, 12 and 10 are also corresponding, right? Okay, and so what I want you to see in this one, you can tell that 12 is more acute than 10, just by looking at it. But you can also tell, yes, they are corresponding, which should make them congruent if the lines that influence them, S and R, are parallel, which they aren't, okay? So when they're not parallel, those lines that influence those angles with this transversal, then we cannot claim that these two are going to be the same measurement, okay? It's got to be these two because these lines that influence them are going to be parallel, okay? So that's how I want you to do that section right there. To finish things off, looking at one last problem, okay? Number 21 says this, find the value of the variables in each figure. Explain your reasoning, okay? So I guess what I would do is this. I would start with the angles that have the same variable. So here we have two y's. So what I'm going to do is I'm going to redraw those two lines. I'm going to redraw the transversal, 5y minus 4 degrees. And then we have 3y degrees. Okay? Now, as we look at this, notice these arrows here. I didn't mention this before, but remember those arrows mean that they are parallel. So I'm going to go ahead and put this down here to show that they are parallel to each other. Okay, now there's lots of different ways to set this up, to go ahead and solve for the angle. I'm probably going to do something like this. These vertical angles are congruent right here. Okay, so as a result, this angle and this angle are consecutive interior angles. So I'm going to go ahead and say that my equation is going to be this, 3y plus 5y minus 4 is equal to 180, okay? Now how can I set that up? I'm going to say the consecutive interior angles theorem. Okay, THM is how I abbreviate theorem there, okay? And then I'm going to go ahead and solve. So we have 8y minus 4 equals 180. I'm going to add 4 to both sides. And I'm going to divide by 8. 8 goes in twice, 24 would be 3. I believe it's 23 degrees, okay? Yep, 23 degrees. Now, to figure out what x is going to be, I can actually draw either angle, this angle here or this angle here to go along with this one. I'm actually going to draw these two right here. So I'm going to go ahead and do those two lines and then the transversal. And then I'm going to go ahead and do, this is 3y and this is 2x plus 13. Okay, and again, these lines are parallel. Now, if I ask myself what type of angles are those two angles, I'm going to go with the fact that they're corresponding. So I'm going to say that this is the corresponding angles postulate. Okay, and so the equation is going to be that those two angles are equal. Okay, and I'm going to plug 23 in there for y. This would be 69. If I subtract 13, I get 56. And x will equal 28. Okay, x, sorry, went off the page there. X will equal 28. Okay, so hopefully that made sense. How once you setting these up and figuring these out, you can break them down in parts like we did there in number 21. But I want you to go ahead and finish up the rest of that page for me. If you have questions, as I always, please come back and talk to me. We'll talk to you later. Good night.